Yes, our next topic is colligative properties. So colligative properties are those properties of solution which depend on number of particles of solute but do not depend upon the nature of solute. Those properties which depend upon the number of particles of solute but do not depend on nature of solute are known as colligative properties. There are four colligative properties. First is relative lowering in vapor pressure. Second is elevation of boiling point. Third is depression in freezing point. And fourth is osmotic pressure. These are four colligative properties which depend on number of particles of solute but do not depend on nature of solute particle in solution. And these are relative lowering in vapor pressure, elevation of boiling point, depression in freezing point, and osmotic pressure. So let us discuss all these colligative property one by one. First is relative lowering in vapor pressure. In last lecture we have discussed the vapor pressure of any liquid solution. Now first colligative property is relative lowering in vapor pressure. Suppose you have a liquid, any pure liquid, at any particular constant temperature. First observe the vapor pressure of this pure liquid, and to this pure liquid if some solid solute is added, then the vapor pressure of this solution will get decrease. The decrease in vapor pressure will depend on the number of particles of solute in solution but do not depend upon the nature. Suppose there are two liquid solutions. In one solution, suppose 1 mole of glucose is dissolved to form a solution, and in another solution, suppose 1 mole glucose and 1 mole of sucrose. 1 mole of glucose is present in definite amount of solvent to form a solution, and there is another solution in which 1 mole of glucose is present in liquid solution. Then we observe that the lowering in vapor pressure of both these solutions is same, because both these liquid solutions have same amount of solute, that is 1 mole of sucrose and 1 mole of glucose. So both these solutions have same vapor pressure because the number of particles of solute in the liquid solution is same. So those properties which depend upon the number of particles of solute does not depend upon the nature, and that first colligative property is relative lowering in vapor pressure. Means after dissolving some solid solute, the vapor pressure of solution will get decreases. This is known as relative lowering in vapor pressure. Suppose we have a pure liquid. We have any pure liquid. To this pure liquid, dissolve some solid solute, and this solid solute is non-volatile in nature, means the component which cannot change into vapor. Then due to this solid solute, the vapor pressure of this pure solvent will get decreases. This is known as lowering in vapor pressure. That is, when some non-volatile solid solute dissolve in a liquid solvent, there is decrease in vapor pressure of this pure solvent. This is known as lowering in vapor pressure of this solvent by dissolving the non-volatile solid solute, which is known as lowering in vapor pressure. That is, suppose the pure liquid which can vaporize. Now this solution contains some solid solute in which solid solute cannot change into vapor. Then vapor pressure of this solution is only due to presence of this pure solvent. That is, vapor pressure of solution is equal to vapor pressure of solvent only. अगर हम किसी प्योर सॉल्वेंट में कोई सॉलिड सोल्यूट ऐसा डिसॉल्व कर देते हैं जो कि सॉलिड सोल्यूट नॉन वोलेटाइल रहेगा, उसकी वजह से अब ये जो प्योर लिक्विड है इसका वेपर प्रेशर हमारा डिक्रीज हो जाएगा, क्योंकि सॉलिड सोल्यूट ऐसा है जो कि नॉन वोलेटाइल है, जो खुद वेपोराइज नहीं होगा. दैट इज द सॉलिड सोल्यूट कैन नॉट चेंज इनटू वेपर. Vapors are formed only of this pure solvent, that is the liquid, which is volatile in nature. Now, on dissolving this solid solute in the pure solvent, vapor pressure of solution will depend upon the vapor pressure of solvent only, because this solid solute is non-volatile in nature, which cannot vaporize. Because now the vapor pressure of this solution is only due to presence of solvent only. And according to Raoult's law, vapor pressure of solvent is equal to mole fraction of that component, mole fraction of solvent into vapor pressure of pure component. This is Raoult's law. So, vapor pressure of any liquid solution, PS is the vapor pressure of solution, is equal to vapor pressure of solvent only. And the vapor pressure of solvent is equal to mole fraction of solvent into vapor pressure of pure component. That is, vapor pressure of solution is equal to P0 into X1. Vapor pressure of solution is equal to vapor pressure of pure solvent into mole fraction of this pure solvent. PS is the vapor pressure of solution and P0 is the vapor pressure of pure component, that is of only solvent which is volatile, and X1 is the mole fraction of solvent. Then by rearranging, PS by P0 is equal to X1. PS is the vapor pressure of solution and P0 is the vapor pressure of pure solvent, that is equal to mole fraction of solvent in this solution, which is formed by dissolving some non-volatile solid solute to form a solution. Then PS over P0 is equal to X1. PS is the vapor pressure of solution and P0 is the vapor pressure of solvent, is equal to mole fraction of solvent in this solution. And what is X1? X1 is the mole fraction of liquid component which is volatile, and mole fraction can be calculated as number of mole of this component by number of mole of solute plus number of mole of solvent. So replace this X1 by this value. PS by P0 is equal to N1 by N1 plus N2. N1 is the number of mole of this solvent, number of mole of solvent plus number of mole of solute. From this equation, subtract each side from 1. 1 minus PS by P0 is equal to 1 minus N1 plus N2, and P naught minus Ps over P naught is equal to N1 plus N2 minus N1 by N1 plus N2. So P naught minus Ps over P naught is equal to N2 over N1 plus N2. So P naught minus Ps, P naught minus Ps, this is known as lowering in vapor pressure of solution by dissolving some non-volatile solid solute in solution, and P naught minus Ps over P naught, this is known as a relative lowering in vapor pressure. P naught minus Ps over P naught is the relative lowering in vapor pressure, that is equal to N2 over N1 plus N2. And what is N2 over N1 plus N2? This is known as mole fraction of solute in this solution. That is P naught minus Ps over P naught. This is known as relative lowering in vapor pressure. That is equal to X2. And what is X2? This is mole fraction of solute, and this is known as relative lowering in vapor pressure. So relative lowering in vapor pressure is equal to mole fraction of solute. Relative lowering in vapor pressure is equal to mole fraction of solute which is non-volatile in solution. So this formula can be used for calculation of mole fraction of solid solute in the liquid solution. And what is X2? This is the mole fraction of solute, that is equal to N2 over N1 plus N2. Then if the solution is dilute, if solution is dilute solution means the amount of solvent is very large as compared to amount of solute. That is N2 is very small as compared to N1. N1 is the number of mole of solvent, N2 is the number of mole of solute, and N1 is the number of mole of solvent. So in this formula, from the denominator N2 can be neglected in case when the solution is dilute. So this equation becomes P naught minus Ps over P naught is equal to N2 over N1. This is the formula which is used for the calculation of number of mole of solute in liquid solution. P naught minus Ps over P naught is relative lowering in vapor pressure, that is equal to N2 over N1. This formula is used for dilute solution for calculating of molecular mass of solute, and N2 is the number of mole of solute which is calculated by given mass of solute by molar mass of solute, and N1 is the number of mole of solvent, that is calculated by given mass of solvent by molar mass of solvent. So P naught minus Ps over P naught is equal to W2 by M2, that is number of mole of solute, into W1 by M1, that is the number of mole of solvent. If solution is not dilute, that is the solution is concentrated, then use the formula P naught minus Ps over Ps is equal to N2 over N1. So this equation can be used for calculation of N2, that is the number of mole of solute present in a known amount of solvent. And by this formula, we can calculate the M2. And what is M2? Molecular mass of solute. So by using this colligative property, relative lowering in vapor pressure, we can calculate the molecular mass of solute in a liquid solvent. So this is our first colligative property, relative lowering in vapor pressure. Relative lowering in vapor pressure is equal to mole fraction of solid solute which is present in liquid solvent to form a solution. And all the colligative properties, that is the relative lowering in vapor pressure, elevation of boiling point, depression in freezing point and osmotic pressure are being studied for those liquid solutions which are ideal solution. That is, the solution is dilute and the solid solute is non-volatile in nature and non-electrolyte. That is, all the colligative properties in which solute is non-volatile, solute is non-electrolyte and solution is ideal. So this is our first colligative property, relative lowering in vapor. Yes. So our first problem on relative lowering in vapor pressure, and the problem is vapor pressure of pure benzene is 0.850 bar. If to this 0.5 gram of non-volatile and non-electrolyte solute is dissolved in 39 gram of benzene, vapor pressure of solution becomes 0.845 bar. Then calculate the molar mass of solute. That is, we have a pure solvent benzene weighing whose weight is 39 gram. To this 39 gram of benzene, a solute which is non-volatile whose mass is 0.5 gram is dissolved to form a solution. Then after dissolving 0.5 gram of this non-volatile solid solute, vapor pressure of this solution, that is PS, will becomes 0.845 bar and vapor pressure of this pure benzene is equal to 0.850 bar at the same temperature. Then we have to calculate the molar mass of this non-volatile solute. This is our target. And the formula used for calculation of molar mass of solute is P0 minus PS over P0 is equal to X2. And what is X2? X2 is the mole fraction of solid solute which is non-volatile, that is W2 by M2 into W1 by M1. So our target is to calculate the molar mass of non-volatile solute. P0 is the vapor pressure of pure benzene and PS is the vapor pressure of solution which is formed by dissolving 0.5 gram of non-volatile solid solute. And P0 is the vapor pressure of pure solution. W2 is the mass of solid solute which is dissolved in 39 gram of benzene, and M2 is the molar mass of solute. W1 is the mass of this pure solvent, and M1 is the molar mass of benzene. And formula of benzene is C6H6 and molar mass of benzene is 78 gram per mole. So our target is to calculate the molar mass of solid solute. And what is the value of P0? P0 is the vapor pressure of pure solvent and PS is the vapor pressure of solution which is formed by dissolving the 0.5 gram of non-volatile solute, and P0 0.850 bar, that is equal to W2. W2 is 0.5 gram and molar mass of this solute is to be calculated, and W1 is the mass of solvent which is 39 gram into molar mass of benzene is 78 gram per mole. So we have to calculate M2. So solving this 0.005 by 0.850, that is equal to 0.5 into 78 by M2 into 30. So we have to calculate M2, that is equal to 0.5 into 78 into 0.850 by 0.005. So by calculating this becomes into 39. So 0.5 into 78, that is equal to 39 into 0.850 by 0.005 into 39. So M2 is equal to 0.850 by 0.005. Then calculating by this, M2 comes out to be 170 gram per mole. So molar mass of this non-volatile solid solute is 170 gram per mole. Thank you, students.